Hi, welcome back to 3.2. This is the second part of the video, and we're going to look at synthetic division in this one. So it's a form of polynomial division that just uses the coefficients of each equation. The first step, just looking here, we're going to rearrange the equation in descending order. So that's by the powers of x that are there. We're going to use the divisor to solve for x. So, for example, if the divisor is x plus 2, we're going to use minus 2. And we're only going to write the coefficients of the equation. If any of them are missing, this is key. You put a 0 in that spot. That, I would say, is probably the most common error that happens. And we're going to make an L shape with a value of x outside. And then I'll run through these steps as I'm doing it. And we're going to be repeating 4 to 6 until we get our last remainder. Okay, so let's have a look at this first example here. It is x cubed minus 2x squared plus 6x minus 12. And it's going to be divided by x minus 1. So since we have x minus 1, we're going to use 1. All right. And so this is what you're thinking. X minus 1 equals 0, and then solve for x. So x is equal to 1. That's what you use. So we're going to use 1 as our divisor. And the coefficients that we use are from here. So this is a 1. This is a minus 2. This is the 6 and a minus 12. So let's rewrite that in our L shape that I was talking about. So there's our 1, that's our divisor. Then we're making an L shape here. And we're going to write the coefficients from right up here. Okay, so you've got your 1, your minus 2, your 6, and your negative 12. First thing you're going to do is bring down the first coefficient, and we're going to write a 1 there. Okay, then what we do is we take this divisor and we multiply it by this number here, and we write the answer there. Okay, so that's 1. Now what I do is I add down. So adding that gives me negative 1. And I'm going to take this divisor, multiply it by that negative 1, and write the answer up here. So that's negative 1. Now I'm going to add down. That gives me 5. I'm going to take this, and I'm going to multiply it by this 5, and I'm going to write the answer up here. And I get 5 as my answer, and then I'm going to add down, which gives me negative 7. So this right here, this is our remainder. And you saw that took mere seconds compared to the polynomial long division. So if we were to write this as our final answer, we would have 1x squared. So these are the coefficients. That's the variable, the power of x that's attached to each one. And so we've got our minus x, we've got plus 5, that's our constant. And then we're going to write our remainder so that it is that should be a minus, and 7 over the divisor, which is x minus 1. All right. So have a look at this next question here. This is missing the x term. So do you remember what to do for that? Well, we're going to use the coefficients 2 for the x cubed, 5 for the x squared, and 0 for the x because it's missing, and then 9 for our constant. All right, making our L shape here, we're going to be using the opposite of this number here. So it's going to be minus 3 that we're using. Same procedure. Why don't you press pause on this and see if you can get the answer. Okay, so now I'm back. I'm just going to quickly run through this. Okay, so this one, since this is 0, this has no remainder. All right, so our answer we can write like 2x cubed plus 5x squared plus 9 over x plus 3 is equal to 2x squared minus x plus 3. You could also write it like this. 2x squared minus x plus 3. And if you were to multiply that back out with the divisor, we would end up with 2x cubed plus 5x squared plus 9. Okay? All right, perfect. Now, there is one last question here. I want you to try this one, and bring this one to class. Okay? So try it yourself. I'm not going to show it on the video. So there. Okay. All right. So this is what you've all been waiting for, the remainder theorem right here. Okay. So what it does is the remainder theorem allows us to obtain the value of the remainder without actually doing any dividing at all. What happens? Okay. So let's look at this first example. We're going to determine the remainder when the polynomial p of x equals x cubed minus 5x squared minus 17x plus 21 is divided by the following binomials. So here, this is our divisor in the first case. We're going to use -1 to do our synthetic division. So very quickly, running through the synthetic division here, we're going to set it up with our coefficients. So I've got 1 minus 5 minus 17 and 21. Bring down the 1. And why don't you guys hit pause and get a second to figure out what the answer is and tell me what the remainder is. Okay, so now that you have given this an attempt, hopefully, I'll just quickly run through this here. This times this, 6, add these two going down, -11. This times this, +11, add these two, 32. So right here, this implies that my remainder is 32. All right, now, if I use the remainder theorem, that means that all I have to do is in my polynomial up here is plug in that value, -1, and I should get the same value as that right there. So let's go ahead and do that. And I've got -1 cubed minus 5, -1 times -1 squared minus 17 times -1 plus 21. And if I go through the arithmetic, I can see that I end up getting 32. So this means that if I try dividing by x plus 1, here I'm trying to write a -1 over here, that I will have a remainder of 32. Okay, so here's another example, exact same question. Why don't you try this one? Okay, so first do the synthetic division up here, and then you can verify it using the remainder theorem down here, and bring your answer to class, and we'll talk a little bit more about the remainder theorem then. Okay, maybe I'll spoil it for you. You should get the answer remainder of -48. Okay, so hurrah, hurrah, if you got it. And we'll have a look at these questions. Take care. Bye.